According to physicist Peter somebody or another, the key to a successful foul shot in basketball lies in the arc of the shot. He determined the optimal angle of the arc from the free throw line to be 45 degrees. So carefully shoot the ball at 45 degrees. The arc also depends on the velocity with which the ball is shot. If a player shoots a foul shot, releasing the ball at a 45-degree angle from a position 6 feet above the floor, so you've got to be tall enough for that to happen, then the path of the ball can be modeled by the quadratic function. So this quadratic function would not model me, ever, because I'm not that tall. Where h is the height of the ball above the floor, x is the forward distance of the ball in front of the foul line, and v is the initial velocity with which the ball is shot in feet per second. Okay, suppose a player shoots a ball with an initial velocity of 28 feet per second. Determine the height of the ball after it has traveled 8 feet in front of the foul line. So for part A, we use our function, and we want to know what the height of the ball is after it's been from 8 feet in front of the foul line. So the x value is 8. The formula is negative 44. So that means it's x squared, so we'll plug x in there. Over v squared, did it tell us what the velocity was? 28. Yep, 28 feet per second, so we put that in there. And then the rest of the function is plus x, so in that case it's 8 plus 6. So you put this in your calculator, for negative 44 times 8 squared divided by 28 squared plus 8 plus 6. You shouldn't need any special parentheses or anything in this one, because it will do order of operations just fine, your calculator will. Okay, so you guys should be able to find that, right? So step B is just like step A, except what are you plugging in instead? 12 instead. Same exact numbers, you're just putting 12s where the 8s are. Okay? Next step, find some additional points and graph the path of the basketball. So far, I would need numbers for these to know these answers, and I wasn't going to go ahead and find them. But if you go ahead and find your number answers, of course, one of them is going to be at 8. 1, 2, 3, 4, 5, 6, 7, 8. So you'll have a point at 8 something, whatever the height ends up being, right? And then you'll have a point at 12 something, whatever that height is. I'm assuming it's higher. It's lower? Oh yeah, because that's a negative. That makes sense. Anyway, so you're supposed to find some points and graph it, or you could put the whole thing in your calculator to graph it. Have you guys gotten a graphing calculator app you can use yet? If you haven't yet, you need to download a graphing calculator app. We'll talk about that in a minute. Okay, last step. The center of the hoop is 10 feet above the floor and 15 feet in front of the foul line. Will the ball go through the hoop? Why or why not? If not, with what initial velocity must the ball be shot in order for the ball to go through the hoop? Okay, so for step D, so C was graphing. For step D, we have to plug in 15. And we go ahead and calculate the number. Plus 15 plus 6. So using a calculator, we're going to put in negative 44 times 15 squared divided by 28 squared plus 15 plus 6. So 8.37 is the height of the ball. How high did they say the hoop was? Where's the hoop? What did the problem say? Are you guys awake? The problem said that the hoop is at 10 feet. If the ball is at 8.37 feet when it reaches the hoop, is it going to go through it? No! The answer to that would be no. Okay, So then the second question is, okay, so then it says why or why not? Well, it's not high enough in the air to go through it, right? So then the second part of the question is, well, let's figure out how high it needs to be. So we need the height to be 10. We need, and the 15 isn't going to change. What is it that changes for this problem? What variable are we trying to change to make the ball go through the hoop? V, the velocity, right? So to solve for v squared, let's go ahead and add 15 plus 6, so that's 21. Subtract the 21 from both sides, so that gives us a negative 11 on this side. And then cross multiply. So after I've done those steps, I end up with negative 11v squared equals negative 44 times 15 squared. And if you go ahead and put that in your calculator, you get like negative 9,900. So then when you divide by the negative 11, you get positive 900. And that's v squared. So then how do we find v? Square root the 900. So what will the needed velocity be? 30, because the square root of 900 is 30. So instead of shooting the ball at 28 feet per second, it needs to be 30 feet per second, so a little bit faster. So you should be able to go back and do parts A, B, and C. I did part D for you. But part A and B are just plugging in the numbers like I did the 15. And then part C is just graphing the points you found, making a graph that represents the path of the ball.